Hello students, this is an introductory lecture to Unit 1 of Engineering Mathematics 2, and the first unit in Engineering Mathematics 2 according to the syllabus for SPPU is first order ordinary differential equations. So in this unit there are basically according to the syllabus this unit is divided into 4 topics. The first topic according to syllabus is exact differential equations. Second topic is equations reducible to exact form. Third topic is linear differential equations. And fourth topic is nothing but the Bernoulli's equation. So we'll not be directly going towards exact differential equations. We'll be starting with the topic of linear differential equations and then Bernoulli's equation, then exact differential equation, and then equations reducible to exact form. So in this way we'll be conducting the lecture. So this will be the first topic, this will be the second topic, this will be the third topic, and this will be the fourth topic. So let's start with linear differential equations. Before going directly towards linear differential equations, it is important to understand certain topics and basics of differential equations. So we'll go towards those basics first. Going towards basic, let us first understand and give a formal definition to this differential equations. So what are these differential equations? They are nothing but a relationship between a function and its derivatives So this differential equation is nothing but a relationship between what? A function and its derivatives. So let us see an example how we can establish this definition. So first example we can write as follows: dy by dx plus 9x is equal to 5. So over here we have y as a function of x, we have a variable x over here, and then the constant. So this equation has everything, the derivatives also over here, the constants also over here, and the variables also here. So a differential equation consists everything. It consists of derivatives, it consists of constants, and it consists of the variables and also the functions itself sometimes. Now let us take another complex example of a differential equation. Now why I am calling it complex, I'll tell you later. So another example can be like this as follows: del 2y by del x square plus 6x is equal to 2. Now why I am using this del over here and why I am calling this as complex? Because this equations over here, this first equation over here, it is basically an ordinary differential equation. Now why it is an ordinary differential equation? Let me tell you that. Ordinary differential equation, it is called as an ordinary differential equation because there is only one independent variable x over here. X is the only independent variable, whereas y over here is dependent on x. On the other hand, when we use the symbol del, it denotes partial differentiation. And when do we use partial differentiation? It is used when we have more than one independent variables. So partial differentiation is used when we have more than one independent variables. Okay. Now this is only the differentiation that we are going to study further. So the first differentiation that we are having in this differential equations is, the first type of differential equation is ordinary differential equation. So the differentiation which we are having for differential equations is as follows, that is we are characterizing these differential equations into two types: ordinary differential equations, and the second is partial differential equation. Partial differential equation. Now what is this ordinary differential equation? It means that there is only one independent variable. And in this partial differential equation, there are more than one independent variables. Okay, so this is the first differentiation that we are doing, that is we are differentiating, or we are dividing the bigger gamut of differential equations into two sections, that is ordinary differential equation and partial differential equation. And in this ordinary differential equation, what we have only one independent variable, and in partial differential equations, what do we have? We have more than one independent variables. Now let us see an example of ordinary differential equation. Now, the example of ordinary differential equation. Now, in this example of ordinary differential equation, as I said, we have only one independent variable. So, let me write an equation. So, this is an example of ordinary differential equation. d2y by dx2 plus dy by dx is equal to 3 cos x. Now, over here, what we are doing is, in this term, in this first term, we are differentiating y with respect to x twice. That is, the y is differentiated twice. Two times we have taken the derivative of y with respect to x. In the second term, we have basically taken the derivative only once. And in third term over here, we have cos x, that is a function of x. Now, in this ordinary differential equation, when we can say that this is an ordinary differential equation? Only when x is independent variable, and y is dependent variable. And y should be dependent on what? Dependent variable. And y should be dependent on what? It should be dependent on x. So this is an example of ordinary differential equation. Now we'll see an example of partial differential equation. Example of PDE. So ODE is ordinary differential equation and PDE is partial differential equation. So for this example, let us consider for say, okay, del u by del y plus del u by del x is equal to 0. Now this is a partial differential equation only when x and y are independent variables. X and y are independent variables, which means that x and y are not dependent on u and also not dependent on each other. And over here we have considered that u will be a function of both x and y over here. Now over here, when we consider del and differentiate with respect to y, so whatever terms in u which consist of x are considered to be constant. And over here, when we differentiate with respect to u, with respect to x, the terms in u which consist of y are considered to be constant. So for example, I'll tell you, if u is equal to, let's say, x square plus y square. Now I'm differentiating u with respect to y first. Now when we are differentiating with respect to y, what did I say? We'll consider the terms consisting x to be constant. So this part now becomes constant, and when this part becomes constant, the derivative of a constant is 0. So del u by del y is only for this function and it becomes 2y. On the other hand, when we write del u by del x, this part becomes constant, that is of y square becomes constant, and we derivate only x square and we get 2x. Okay. So I hope you have understood how to use the partial differentiations and calculate the partial derivatives. Okay. Now let us move further. So further topic which we are going to see is order and degree of differential equations. So the topics which we are going to handle are order and degree of differential equation. Okay, so I'll not continue this order and degree in this lecture. I'll continue it in the next lecture, and I'll post it later. So there will be only 2 lectures for the demo. So if you require more understanding of the topic, you can contact me on the email ID. The email ID is this: sitkamble1896@gmail.com. Okay, so this is my email ID. So you can contact me on this. So I'll be posting a lecture on order and degree, but the other lectures won't be posted on YouTube further. Okay. Thank you for the attention.